Assalamu alaikum students. Today we are going to be learning very basic information about the algorithm. Firstly, we will discuss that what is algorithm, the different types of algorithm, and then the different data structures and data types that we can use while we are doing algorithm or making an algorithm. Okay, so let's begin today's class. The very first thing that we are going to discuss is algorithm. Algorithm is a process of or set of rules to be followed in calculations or in other problem solving operations, especially by computer. What does it mean actually? When we are given any task, so that can be considered as a problem. How to solve that problem? How to find out the final output? So whatever the actions we will be performing, so if we write them in the form of steps, that firstly what we did, then the second thing, then the third thing. So the set of these all instructions is called or is considered as an algorithm. So there are two types of algorithm. The one is pseudocode, the second one is flowchart. You can see the examples of both things. The first one is the pseudocode. It is in front of you. The pseudocode is actually very close to the human language. For example, if you are given if you are given a problem in which you are asked that you have to take one number from the user and then you will add 5 into it and you will give the result. So the very first thing that you are doing is taking the input from the user. You can see here, ask the user to type in a whole number. Then the second step, what you are going to do, you are going to add 5 into the number, whatever the number you have received, and then you will tell what is the result. If we write the same thing, the same steps in O-level pseudocode writing, so we have some specific commands that we are going to use. For taking input from the user, we have a command of input. You can see here, input. So what we are doing, we are taking an input, and whatever the number the user will give, it will be stored in a memory, and that location in the memory will be considered as will be named as number. Okay. Secondly, we are creating another location in the memory, that's name is result, and what we are going to save into it, we are going to save the total of number and 5. So this total will be added into another location of the memory, and that's name is result. And then what you will do, the third step, you are going to print the result. And whatever the result value is there, means whatever the value you have saved in that memory location, that's name is result. So that will be shown. So this is the example of pseudocode. On the other hand, you can see this is an example of flowchart. The flowchart is a pictorial representation of the same steps, the instructions that we are going to follow. For example, the first one, what we were doing here, we were taking the input, we were adding 5 into it, and then we were giving the result. The same thing is happening here. We are taking the input whole number, but as you can see, the box is a parallelogram. It is not a box, it's a parallelogram, the first shape. Okay, so with the help of this shape, you can find out that there is some sort of input or output is going on. Okay, but as we have mentioned here, that is input, so we are taking value from the user. In the second box, you can see that it's a simple rectangle. So rectangle is used for showing any type of process. So what is the process going on here? It is adding the value, the whole number and the 5 together, and then it is showing you the result here. Okay, so the same steps, when we show these same steps in the form of our in the form of different shapes, so that is considered as, that is called a flowchart. Okay, I hope that you must have understood that what is a pseudocode and what is the flowchart. So let's move towards the main topic of today's lesson, and that is the different data types and the different data structure. So first of all, we need to understand what is the data structure. A data structure is a collection of data values, the relationship among them, and the function or operation that can be applied to that data. Means whatever the data we are going to store, what data we will be having in our program or in a pseudocode. So what kind of functions we can perform on those datas. For example, if you are asked to calculate the square root of 9, so you can do it. But if you are asked to calculate the square root of name Ali, you cannot, because Ali's data type is different. We cannot do the calculation on it. Okay, so the different data structures we have, there is very first thing variable, the second thing constant, and the third thing array. There are multiple other data structures are also there that when you will be learning the advanced programming, then they will come in front of you. For example, there is a heap, there is a stack or list, but we are not going to discuss them. In our O-level syllabus, only these three data structures are needed to be focused. And even in array, we just in our curriculum we have only one dimensional array, not even the two dimensional array. So we will be discussing only these three different data structures: the variable, what are the constants and their use, and the arrays and their use. Okay, so let's move further. What are the variables? Variables are data values that can change when the user is asked a question. For example, their age. Variable may change during the program execution. Variable what kind of data is there? Anything that is going to be used in the program and that can be changed during the execution of program. So that is considered as variable. Okay, a variable is a memory location, simply, as we have already discussed, and it has a name that is associated with with that location. The memory location is used to hold data. Okay, there are two different type of variables. One of them is called local variables. The local variables are used only in one specific loop, or you can say in a procedure or in one class, not in the whole program. Okay, so they are considered as local variable. The second one is called global variable. The global variable doesn't is used in the whole program. Okay, means a program can be a collection of different procedures and the classes. So if you are using one variable in one class, it is a local variable. But if the variable is going to be used in different classes in a same program, so it will be considered as global variable. That is, these are the main two differences between the local variable and the global variable. So uh, what is the summary of the variable? Variable is just a memory location in which we can keep or we can store some value, and that value can be changed during the execution of the program. Okay, let's move to the second data type, that is constant. As the variable can be changed during the execution of program, the constants cannot. Constants remain same. They are the values that are not changed during the execution of program. Okay, so what this slide says, data values that stay the same every time a program is executed are known as constant. Constants are not expected to change. Okay, so there are two different types of constants. One of them is called literal constants. For example, if we just write print and under the in between the inverted commas we write this hello world. So every time when you will execute the program, the same thing, hello world, will be written. Okay, but if we save this word hello world in one, if we name it, for example, if we are taking input from the user, and we are naming it as the question, so and then uh, when the question will appear and whatever the user will type into it, and if we print that constant, so whatever, it will not be the constant, it will be the variable, because we are taking the input and the value can be any. But, and what is the use of it, the constants? For example, if I am making a program of let's discuss the second one first, second type of the constant. The second type is a named constant in which we can give a name to the variable. For example, now it will be clearer to you. If I'm making a program in which I have to calculate the income tax of a person, okay? And as you know that the government changed its policy by the end of the year. So if this year I have decided that the income tax of a person will be 2% only, but next year it will be changed. Okay, keep it in your mind. So what is the use of constant? I will declare the constant, the rate of income tax as a constant, and that is 2% in the program. And in the whole program where it is going to be used, I will be using its name, not the value. Okay, and the year changes. The next year government says that we are not going to take 2%, but this year we will be taking 3%. So in that case, uh, I will not have to go through the whole program again and change the values of 2. Okay, if I am using literal constants, so it will be 2, because I will be using the same value 2 in my formulas where I'm using. If I have named it, so what will happen, where I have given it a name, only at that place I will change its value from 2 to 3. And wherever I have used that name of the constant in the whole program, so the backend value of that name that has been changed into 3, that backend value will be used. Okay, so there are two different type of constant, the literal constant, and the second one, named constant. Literal constant is the one that we do not give any name. The named constant is the one we have given some sort of name to it. Okay, so let's move to the third type of data structure, and that is array. An array is a collection of items stored at contiguous memory location. As we have discussed in the on a very first on the first slide of the data structure, that what is the data structure, it's a name of a memory location and the type of it. Okay, so the array is also a memory location, but what is the difference in array and the variables? Variable stores only one value, but array stores multiple items into it. Okay, means it is possible that in our array we have 30 different items or 100 different items or 1,000 different items. Okay, but yes, it is very necessary that they all should be of same type. Means if we are declaring an array in our program, and that is going to be stored names, so we will uh, name it as a name, and we will give its data type as a string. So once we have announced that it is a string, so we will not store any type of uh, integer value or the float value or character value into it. The type should be the same. Okay, and yes, we also tell that in the very beginning of the program, we mention in array that how many items are going to be stored in it. Okay, so it has a fixed size. It has a fixed size. So if we have an array that has 10 different values, we can access any of the value from those 10 values. For example, I want to access, and we have stored the values into this array, and I want to access the value that is stored at the 5th position. So we can access, we can change it. Okay, and those positions where the values are stored, they are called index of an array. Okay, so we can access those elements whenever we want in our program. Let's move further to the different data types that we can store. So mainly there are 5 different data types that we are going to discuss, and these 5 data types are included in your O-level syllabus. Okay, so the very first data type is integer. Integer holds the number, whole numbers. The second one is floating point, or float, or real, we can call them, and they hold some fractional values. Okay. The third type is character, that stores any one letter, either it is printable or non-printable, visible or invisible character. Strings, the fourth type, and the fifth type is Boolean. We are going to discuss all of them in detail. Okay, so the very first data type is number. In the number, we have 2 subtypes. One of them is called the integer. Integer is a data type that holds the whole number. Those numbers can be positive or they can be negative. Okay, but yes, if you are given a name to that as integer, so you are not going to store any fractional value into it. Means if you have declared a variable and its data type is integer, and afterwards you want to store 2.5 into it, so it is not going to be stored in it. Okay, for the real, for storing the decimal values, we have the other type that is called real, or it is also called float. You can name it, you can use both the names, and these values can also be positive fractional value and negative fractional values. We, in the different computer languages, we have different names, different different data types of the real. Actually, when we declare any data type, so actually what do? We tell the processor that what kind of values are going to be stored, and according to that data type, is the processor keep our processor keep that assign that variable is some storage capacity. As in the previous slide, we have seen that when we are assigning a data as an integer, so the values that can be stored into it, it can be from 1 byte to 8 bytes. But if it is float, so it is starting from 4, not 1, because at least it will be having decimal into it. So it can be 1.1, 0.1, or 0.25. It can be added. So what happens in the processor assign its more storage capacity. Okay, so if we are using the correct data types, so our program is going to be efficient. It will work faster, and our uh, internal memory is not going to be flood out. Okay, so the first data type was integer, and the second data type was real, and they both are used for numbers. The difference is the integer stores whole numbers into them, and the real stores decimal values. Let's move further. The third data type, and that is string. Whenever we declare any variable as a string, so what kind of values it can store into it. It can be any character that we have in our keyboard. It can be the alphanumeric characters. It can only have the alphabets, it can only have numbers only, and it can also have the collection of both of them or the special characters, any of them. Okay. And the when we declare any variable or any array as a string, so it has the biggest capacity. Why? Because for example, if you are going to store your um, home address, it will be very, very long. For example, house number 12345, and then the street number there's, and the area, and then the city, then province, and then the country. So it is assigned bigger storage capacity. Okay. So whenever we assign any variable as a string, we declare any variable as a string, and we store any value. So what happens? The ASCII codes of those values are going to be stored into that variable. Okay, let's move further. Two more data types. One is character, the second one is Boolean. Character holds only one character. It can be a number, it can be a letter, it can be any special character, anything, but only one. Okay, every letter, digit, and punctuation mark is a character. There are also many characters that are invisible on screen, such as the space, tab, or any other characters. They are going to be stored into that data type. Okay, so when we declare any variable as character, so it is given only 1 byte. The memory storage capacity will be of 1 byte because it is going to store only one character. Okay. For example, where do we use it? For example, if I want to maintain the attendance of students, so it is good enough for me to write P for present or A for absent. Only these two values. So why should I going to declare it as a string? If I declare it as a string, so I can store there the whole word present. And if I store the word present, so present means at least 7 byte memory will be consumed. But if I declare it as a char, so it will be storing only one character. P is good enough and it will be assigned, it will take only 1 byte. Okay, so the same type of it is similar to it, the other data type, that is Boolean, but it can store only two different type of values. Either the value is true or the false. Okay, if we store true, so the whole byte is 1 it will be stored in the whole byte. And if we store false, so the value of the whole byte will be based on zeros. Okay, the same thing, if I store true, so it will take at least 4 byte space. Or if I am storing it as false, so it is going to store at least 5 bytes. But if I declare it as a Boolean, and then if I store true or false, so it will be taking only 1 byte of memory. So with the help of using these different data types, we can make our program more efficient. That is the main reasons why we are learning the different data types. So I think that is good enough for today's lesson. See you in the next class. Thank you and Allah Hafiz.